What? Keep having your conversations. That's what this stop is for, is just more interaction and more wheat to look at. And feel free to walk up and down the plots. You know, you can, see, there's a lot of things to see here. What overall, in general, what we're looking at is our breeder seedlot production. So we develop wheat varieties here at MSU, and in order to reach the marketplace quickly, there are a lot of steps, right? There's a lot of orchestration that goes into getting a variety on 20, 50, 70,000 acres. That would be a lot of acres, 70,000 acres in Michigan. Some varieties have hit that. But right here, we got a new soft white wheat right here. If you're a white wheat grower, it's got some Shirley in the pedigree. That's why we got these blocky like thumb-shaped heads. That's really coming through. We got Shirley through an Ohio State parent on this one. But can you see how clean the flags leaves are? These well, they've gotten a fungicide, right? But this particular variety has something that none of the soft white wheats have, leaf rust resistance. I know you haven't seen it, you don't think about it, thank God, because we were in the firing line. The leaf rust problem moved from Alabama up to Kentucky, and we're only 2 weeks away. We're only one rainstorm away from Kentucky if those winds bring that north. So we dodged a bullet this year, but stripe rust is a problem every year. So this variety has some stripe rust resistance. It's pretty equivalent to slightly better than what's in the marketplace for head scab. We do our best, right, across the board to get everything. In general, what you're seeing out here that's causing this massive stunting and differences, this is cephalosporium stripe, and this is a vascular pathogen during early vegetative growth. In that somewhere in that Feeks 3 to 6 stage that Dennis was talking about at his stop, where we had a lot of overgrowth of roots, excess root growth when it was warm, and then it freezes and it fractures those roots, and that pathogen will get right up into the vasculature. It'll crawl all the way from the soil all the way up, and so you can kind of see the striping on the flag leaf there. It generally goes down the middle, but you can't see it on the sides. So that's what you're seeing, and it's random where it hits. There is a genetic effect. You can see this one's more tolerant versus this one is less tolerant. And we might just walk, if you all don't mind. You can walk and have a little look at things here. This variety is one of those that you saw with resistance to scab. You were introduced to this variety. This is our MI22R0097 formerly. So here's a good, it does get this pathogen, but it doesn't have, here's some of the symptoms of that thing, where if you see that, this pathogen is everywhere, but it never really reaches critical levels. Like I see it in Toledo, and it's Tiffin, Ohio, which is kind of southeast of Toledo every year. We do have a little bit of head scab out here though, Dwight. It's showing up sporadically in places, so it's just field to field, just keep an eye on.
Are these varieties that we're looking at available today or tomorrow?
There is one up the hill, yeah. MI20R12 is available up the hill. Yeah, this would be available for licensing, and everything we're looking at right now is in the commercial yield trial in Michigan this year, right? So all of these varieties that we're looking at are in their 4th year of testing, so they're ready to graduate into the commercial marketplace if they perform well enough. That has to be a couple factors determining that. It has to have performance similar or better. In terms of trait package, this line has resistance to all 3 rusts: leaf rust, stripe rust, and stem rust. You haven't heard that. Your great grandpa probably dealt with stem rust back in the 1930s and 40s in Michigan. It's been controlled with genetics across the board, so it hasn't evolved and adapted to new varieties in the U.S. But we've got resistance to a whole suite of pathogens, including Fusarium head blight. Now I have to test this. Now I need to get this variety to Kaylee, who you met, who's working on wheat streak mosaic virus, according to molecular markers. So we do genomic testing on all of these. If you may have, folks in the animal world will know, anybody doing heifer replacement knows about this, where you can take a sample from their ear and then predict your butter fat, your feed efficiency, all of these things for your animals. We're doing the same thing where we do genomic testing on them and predict what traits they're going to have. And you can also look at different pieces of the chromosome to tell what traits it's going to have. So what I'm getting at is I think it has wheat streak mosaic virus resistance. WSM2 is the gene. There's only 2 genes in wheat, and we got the good one that we can use. So this line, and then some material I think from KWS cereals also has that gene. So it's rare, but I think we have it in this particular variety this year. So if that is in fact a factor in the variety trials, we've seen it everywhere. And And so having a trait like that can really resolve differences in variety. So we can see a yield, a performance benefit from that. So,
Falling number.
what's that?
Falling number.
We're going to get that data this year on it, and we've had that falling number instrument for 2 years now, and so last year was the first year that we ran through the commercial variety trial. So this is in the past we've just been using visual sprouting on all of this, which was in soft white winter wheat. It's a pretty good proxy, but in the soft red, so you got a really good linear response between your visual sprouting and your actual falling number. It was really good. Red wheat, the curve is more flat like this, where it only goes up to a certain, it kind of flatlines, and that was the initial research. But that said, you can still get a 150 falling number or 200 falling number on a red wheat too. So don't, that's still possible. But what essentially what we've done is shifted to what the industry is using in terms of testing, right? We don't really look for any sprouted. If you have sprouted grains, you're already at 150. We're done here. That's not even a thing, right? So this line will, and I believe should have a pretty good falling number. There are different.
Red?
This is a red. This is a red. Yep.
And this might be licensed.
It's potential. Yeah, it has potential. We don't know. We'll see how. When the data comes in. The data has been looking pretty good. There's the white wheat down there, MI22 W213, will have falling number resist. So if I showed some data at the annual meeting, in this summer, it's summer meeting too, where there's a lot of variation among soft white winter wheats. For 48 hours of misting, 2 days, there are some that just crash, right? 60, 100 to 60 to 100 falling number, but there are a couple that do maintain a high falling number with 2 days, 48 hours. When it drops off pretty quick after that. That is a sibling of that line. They're nearly identical for every trait. So that line should have very good, very high falling number under sprout conditions. So that will be that and the leaf and stripe rust resistance. Those don't really exist in the soft white wheat germplasm. So it does fit a good niche in the marketplace. So there's rationale to release it. So we can move up the hill a little bit here. Yeah.
These did or didn't have fungicide on them for the purpose of checking one against the other?
These did actually. I believe I have to check. I'm not sure. They did. Amanda manages the farm. This is Amanda Noble actually. She's who I mentioned before, who collected all the visual data in the scab nursery. This is her. So thank you, Amanda. So they did. Now here's another soft white wheat that does really well. It's got some scab resistance and a good foliar package, but you can see it does have issues with cephalosporium. So it's making me reconsider this line to a large degree. And this line right behind us here is going to have really good FHB resistance. So it's got the FHB1 resistance gene. Oh, in terms of canopy architecture as well, this is going to be one of the more lateral canopies, the droopy types, versus that R97 that we just looked at. That's got the most narrow tiller angle, right? So this line, R135, it's going to be flat. It's going to fill a canopy in a 7.5-inch row, versus that line it's very upright. All the tillers are very close together and upright, and that's something that you can squeeze into a narrow row system, right? So and that line is going to be getting a lot more light into that canopy. So it's doing a lot more photosynthesis, returning a lot more biomass per sunlight unit, right? So you can see all kinds of that variation in these plots here. Good. Other comments or questions? Let's keep.
So are you working with growth regulators to try to
We-
make those heads shorter?
We haven't. Now, thank you for bringing that up. I wanted to mention that there isn't as much. There's differential responses from varieties to these PGRs, to the growth regulators, right? They have, it's all, and gibberellins are the family of plant hormones that work on elongation, right? That's what's going to make the cells are longer and the plants are going to get taller.
Faster extension of the cells.
And they have the responsiveness to those gibberellins is genetically controlled, and so they're different. So what I'm saying is that there are some varieties can respond more or less to those PGRs. Now, and there isn't as much variation with Palisade, but when we think about CCC, the chlorine chloride, I mean, it's in process right now. It's not in the marketplace in the U.S., but that is something I want to do this fall, is to put out have a greenhouse trial in parallel with a field trial looking at variety responses specifically to CCC, because
to track the variety
yes,
and the responses.
exactly. So if that's part of your management program, here's a variety that will respond in a greater way. So when you spend the money on that chemical, that you're getting,
The right one.
yes, exactly. So yeah, yes, we're looking at possibly for next year. This was a really good line. This is MI20R210. This is actually in its 5th year of testing in the program. Really short plant architecture, really broad canopy, but also, well, you could see the spatial variation too. I was gonna say it is susceptible, right? Most varieties are, but all of the variation in response to this pathogen it's localized based on the field. So I'm standing right on a pocket of it. Right under my feet is fungal biomass right now. But if I walk this way, right, can you see the crop change? There's less and less and less of it, right? So there's less fungal biomass out here now. So it's all field effect, right? So it's very hard to make genetic progress on a trait that the variation for which is mostly due to the environment. So that's heritability for the folks in my genetics class, the percent of the trait that's variable based on genetics versus the field effects. So, and that...
The height difference in some of those, did some of them just come up earlier, do you think?
These are infected, so these were infected tillers, infected heads.
So they stopped.
Yeah, exactly.
Inoculum is...
It's coming from the soil, so it's cephalosporium stripe is the disease. And so it'll when the roots break, when there's growth during the day and then freezing at night, it creates fractures in the roots, and that pathogen will find its way in. Similar to like Gauss's wilt in corn after a hail event, right? That's when you're going to see something. Gauss's wilt, that's nobody talks about that much, right? That's been 12 or 13 years ago. But that was before tar spot even. So, but anyway, same kind of thing. It's a natural opening, it gets in there, but it's random how it gets how it's.
Fungicide treatment in the fall would have no effect on it.
I don't think so. I don't think there's enough residual, unless it would be. I don't think there's enough residual, and it doesn't. Yeah, and it's in the roots too, so it's hard to apply down there. And I don't want to fumigate 500,000 acres of wheat in Michigan. That's too much. So.
Is there a yield drag because of that then?
Yeah, big time. If it feels, the best way to avoid this is crop rotation. And this is my fault because we put down oat cover crops, right? And it infects corn, it infects every grass basically. And that's how Fusarium works too. It infects all these grasses, so it's always there. And that's crop rotation. It's back to crop rotation. We're gonna
your soil biome discussion we were having earlier.
Yes,
the
it's
genomics of testing on soil microbes would help.
and you could see proportionally how dominant is this pathogen relative to other, good biomarkers, right? Your mycorrhizae fungi and others.
I wonder if mycorrhizae struggling.
Who knows? It could be, right? There's in one environment where the pathogen thrives, that means that there's a trade-off, right? In the soil microbiome here. So, yeah. So what we're putting in canola as a cover crop this year, trying to get a broadleaf in there to break up the cycle and the pathogen.
That'll probably a little too, right?
Well, we don't want to get into that.
So does this soil tend to be a little bit tighter here?
Yeah, this farm is for sure.
I
Yeah.
always maintain if in the tighter soils, they have a harder time getting the oxygen down into the soil.
Yes.
And the natural defenses for some of those fungal pathogens they're asleep
Right.
because they don't have the oxygen to thrive to control what you like to
Yeah, to
control.
outcompete the bad guys out here, so to speak. Yep. That and it's not every year. It was just this year was the perfect storm for this particular pathogen. I want to show you the worst case of it right here. This is MI 14W190. This is like the most scab resistant soft white wheat that we have in the program, but you can also see, I'm glad it's not out there, because now Jupiter will do this too. There are other types here, and they're we're not actually using this we have the state variety trial here. All the commercial varieties are being tested here. And we've collected like maturity and height notes and so forth. We'll collect yield, but the yield variation is going to be largely due to this thing. And so I'm not going to show you those plots today. I'm a little embarrassed to show you these plots today, but this, you get to see the process. While we're still here, I want to show you the early generation here. So we, just big picture, the breeding cycle, we make our crosses in the greenhouse and we cycle them through the greenhouse quickly. We do something called speed breeding. We accelerate it. So these are in year 3 that we see just to the north of us here. That's year 3. And we select single plants out of this nursery and we put them in a single plot observation. So we go from a single plant to a little 5x5 plot. And then we go to 2 reps at 2 locations, and then we go on to multiple replicates in the commercial variety trial after that. So it's about a 7-year process, which is, we basically have the fastest and cheapest winter wheat breeding program in the country. You could do what we do with double haploids, but we get these plants are about 5 cents a piece versus $50 a piece. You know, you have to have a building and staff. It's about $50 a pop. So we do it for pennies compared to what folks are doing like in industry. Just some more increases as we test these varieties in the field in replicated testing across the state and some across the region too. We have to increase the seed in parallel. So we go out here and we rogue these out. Cephalosporium is not seed borne, or it's not seed transmitted, so we're pretty good in that regard. We're safe. But you can see we have a whole array of on and onless varieties. Pretty good material coming through. Well, up here we've got our single plant selection nursery, and so this is something that Amanda and I went out here together. So when we make these selections, we start with about 150,000 plants and we get it down to about 1,000, about 1,200. So and of course there's a lot of bare ground, so we got some weeds. So we didn't get our Talonor down last fall. That's kind of what our go-to. Okay, so what we've got here is an example of a breeding population. So these are all full sibs, right? Brothers, sisters. So wheat has a perfect flower, so they're brothers and sisters, I guess. But this is what we see in terms when we get out of a cross. So this is a cross with, this is going to be Mackinac, right? So we work with a company that developed it, so we get to cross with it, right? So we got across to a line from Washington State, right? That's got a really good wire 515 stripe rust resistance package and a really good set. It's very different germplasm. It has different yield genes in it, but we're trying to bring them all together in one. But what you can see out here is a lot of difference in terms of height. This is a little bit later maturity, but you can see differences in response to, you know, we've got some different foliar pathogens coming in here. But what we do is we come out here and we tag these, and they all get database. So there's a database with all of these. So when we come out here, we've got our harvest tag ready, and so we're going to pop these out just like turnips and, you know, Super Mario Brothers 2. If you played that one years ago, you just pop the turnips right out. We're going to dry them and thresh them. So these are going to end up in a single plot, just like a nursery up the hill there. We don't have to walk all the way up there, but this is where it all starts. So every wheat variety that's grown starts off in a nursery similar to this, either as selected as a single head and put in a row, or this is what we're doing is relatively novel, these single plants like this. So, but yeah, you can kind of see what we go for. We're trying to select lines that have pretty good height. I mean, this is a little bit too tall, right? Modest height, because you still need some height for biomass, right? If you look at the yen data, there's a 0.8 correlation between biomass and grain yield. So yield is biomass, right? So that's why these early nitrogen applications are important, to get as much biomass on that crop before the grain fill period, because they will use all of those biomass resources will get put into the grain eventually, just like with corn, just like that end is still mobile in the plant, just like with corn. So okay, anyway, any final comments or questions? I think I can wrap up. I could talk all day, but I think I'll wrap it up right there. Anything you see you wanna chat about?
Well, the plant structure of this, of course, is planted a little thinner. And
we space these out deliberately, yeah. So this is the response to spacing. You see all these different tillers, but what we want to see is uniformity in these tillers, right? And so that's where this is very likely going to have an upright plant architecture, right? Where all those tillers and that's part of the biology. There's biological differences, and I think my working hypothesis right now is that these upright architectures, they can tell. Their plants are sensing their environment in the roots. They know how close they are to their neighbor based on the roots, right? And our very preliminary data say that the upright plant architectures will open up in a wider spacing like this. The tillers will widen out. Versus the droopy types, the more lateral canopies, they stay lateral whether they're in a narrow environment or it doesn't matter, or population. They're always going to have a wide tiller angle, but these will adjust to their environment. Is what?
That's good. You get flexibility.
Exactly.
Plant
That's why.
flexibility.
Yes. So you put them in a narrow row system, high population, they're going to go more upright, right? So every plant is going to maximize resource use. Or if you put them in a little more relaxed seeding environment, they will to a point. There's a point they will open up, and they're going to try to take advantage of all of those resources. So they're a little more greedy, so to speak, I think.
Yeah, so I see those really fitting back where they were talking about the 5-inch rows.
Exactly.
They needed to kind of present. That's not really new. It's just new to over here.
It is. That's right.
That's a proven fact.
That's
already
right.
in Europe. So
Yep.
That would be a great fit for that. Keep the population down.
Yes.
Because if they go narrower and raise population, the disease problems and things.
Yes.
No
Yes.
good. Just
Yes.
gonna fall down.
It ruins the yield components then too. It creates scarcity. So wheat behaves a lot like corn, where every single plant has to have the optimum growth environment. We space our corn. There's a lot of precision in corn production. So wheat could benefit from some of that tech as well.
Yeah, these got longer heads than most anything out here. And when you get long heads and square heads,
Yeah.
now you got yield.
Exactly. Good. Well, thank you for your time. I'm glad you could all come on out here, and I'll be around if you got any more. If you want to chat, you got any more questions. I'd like to.
Don't leave yet, 'cause I got the ice cream.
Jody got the ice cream.